Water, water everywhere, not a drop to drink. Isn't this what we feel after the rains? Puddles and water-filled potholes only make us wish that we could make use of the precious water. Actually, we can. Rainwater need not to be wasted. Rainwater harvesting is the best way for using the rainwater. Last decade or so, the distribution of rainfall in many parts of the country is erratic and uneven, which causes water scarcity conditions in many parts of the country, due to which water is not sufficient for drinking, household, agriculture, industries, and other purposes. Also, the groundwater levels in many states have been depleting. We cannot produce water, but one thing is possible, that is to harvest the available rainwater, preserve it, save it, recharge it, conserve it, store it, and use it after proper treatment.
As we are all aware that 18% of the world population is in India, but we have only 4% of water resources. But whereas if you take into consideration the utilization of the water, more than 30% of the water is being utilized in India. This, if you take into account, is a huge utilization in India. Because of urbanization, industrialization, and explosion of the population, the pressure is on the water resources, more particularly the groundwater resources. Mostly our most huge resources available, any resources available in the world is groundwater, but utilization day by day is increasing tremendously. The pressure is very high on groundwater. Because of overutilization and extra utilization of the groundwater resources, there are two kinds of problems arising out of it. One is the declining water level, groundwater levels, and the other is the deterioration in quality of groundwater. Because of these problems, Ministry of Water Resources, Central Groundwater Board is taking up so many artificial recharge structures to control the groundwater level decline and improve the groundwater quality. In this regard, during 11th plan period, 100 crores been allocated for demonstrative artificial recharge in rural and urban area. As a part of this, Andhra Pradesh around 5 crores projects have been submitted and sanctioned to Andhra Pradesh. These structures have been taken up into two ways, some of the structures in rural areas and some in urban areas. Under rural program, we have taken up in Kadapa, Chittoor and Medak districts, whereas in urban area we thought more suitable is the Hyderabad, where it can be put under demonstration to many people. And the two universities have been selected for this. One is the JNTUH, the other is Kakatiya in Warangal city. Why? Because the universities has so young generation people are studying, if they see the impact, so this can be spread the message of artificial recharge, and the message of artificial recharge and rainwater harvesting can be spread among the people, so messages can be passed on. Under this artificial recharge program, Central Groundwater Board has sanctioned 39.9 lakh rupees for construction of artificial recharge in JNTUH campus. In this program, 7 locations have been, suitable locations have been selected for construction of the artificial recharge. Around 10 structures have been taken up. 3 types of structures have been taken up, mainly the recharge pit with recharge borewell. The second is the reuse of rainwater. The third is the recharge borewell in a recharge pond. In reuse of water is a main important one. Here the rainwater which is being collected in the tanks, again being used for some uses other than drinking in the hostels. And the importance of the borewell in the recharge structures is to hasten the recharge process, and a huge amount of rainwater can be sent into the ground to form the groundwater. These structures were very interestingly were taken up. Professor Giridhar meticulously he followed all the guidelines, and also technology as suggested they were modified and constructed very meticulously to so that they are forming the very good demonstrative artificial recharge structures constructed in JNTUH. These structures can be seen by many people and follow in the similar areas, similar structures, so that where we can huge amount of rainwater can be recharged into the groundwater.
To demonstrate how it can be implemented, Jawaharlal Nehru Technological University, Hyderabad has taken initiative for the project on demonstrating rainwater harvesting structure with the financial assistance from Central Groundwater Board, Ministry of Water Resources, New Delhi, with the objective of making university campus as a zero discharge area in the year 2012. In the JNTUH University campus, the available built-up area is 53,822 square meters. Out of the available rooftop area, 11,339 square meters has been considered under this project. The average annual rainfall that the university campus receives is around 810 mm. Maximum water that can be harvested in a normal year is around 75 lakh liters. Under this project, we have constructed 10 rainwater harvesting structures in the university, including 3 piezometers, which are a recharge pond with 2 recharge shafts besides mechanical engineering building, rooftop rainwater harvesting structure with a capacity of 50,000 liters along with 1 bowel for recharge behind old quarters, rooftop rainwater harvesting structure with a capacity of 50,000 liters along with 1 bowel for recharge at new quarters, rooftop rainwater harvesting sump with a capacity of 2 lakh liters for reuse in front of Manjeera Hostel, rooftop rainwater harvesting structure with a capacity of 1 lakh liters and piezometer with a depth of 30 meters along with 2 bowel for recharge behind Tripoli Department, College of Engineering, rooftop rainwater harvesting structure with a capacity of 1 lakh liters and a piezometer with a depth of 30 meters along with 2 bowel for recharge between Girls Hostel compound and new incubator building, rooftop rainwater harvesting structure with a capacity of 1 lakh liter and piezometer 3 with a depth of 30 meters along with 2 bowel for recharge behind JNTUH IST building, Manjeera Boys Hostel. Manjeera Hostel building has a rooftop area of 620 square meters. The rainwater falling on the roof of this hostel is directed to the circular storage tank of 2 lakh liter capacity. The rainwater available from the roof of the building alone is about 4 lakh liters per year. The water is made to flow through PVC pipes of 4-inch and 6-inch diameter into the tank. Proper filtration system has been made at the inlet point of the storage water tank. The water stored into the tank is used for domestic purposes of the students residing in the hostel. Technical specifications of 2 lakh liter structure located in front of Manjeera Hostel JNTUH campus. Capacity of the tank 2 lakh liters. Diameter of the tank 8 meters. Height of the tank 5.3 meters. Rooftop area 620 square meters. Maximum rainwater can be harvested in a year 4 lakh liters. PVC pipeline used 4-inch and 6-inch diameter. Rainwater falling on the roofs of 11 buildings situated in the university campus are collected through PVC pipes of different diameters through telescopic design. After proper filtration, water is allowed to store in the sumps. In each structure, recharge wells are established in the sumps to inject water into confined and unconfined aquifers directly. The diameter of recharge shaft is 200 mm. These wells are used to recharge both confined and unconfined aquifers situated at various depths below the ground surface. These recharge shafts are more beneficial for deep depleted aquifers and also where economy of space is important criteria. Total 5 rainwater harvesting structures were established in the campus in Phase 1 and Phase 2 of the project for recharge purpose. The technical details about these structures were explained in the following video. Recharge structure with a capacity of 1 lakh litre along with 2 recharge shafts in the tank for pre-location located behind EEE department, College of Engineering JNTUH, which covers the rainwater coming from the building of Civil Engineering and Library. Total rooftop area is 1020 square meters. The rainwater available from the roof of these buildings is about 6.60 lakh litre per year. Technical specifications of 1 lakh litre structure located behind EEE building. Capacity of the tank 1 lakh litre. Depth of recharge well 1 30 meters. Depth of recharge well 2 60 meters. Rooftop area 1020 square meters. Maximum rainwater can be harvested in a year 6.60 lakh liters. Size of the tank 5 meter into 6 meter into 3.3 meter. PVC pipeline used 4 inch and 6 inch diameter. Recharge structure with a capacity of 1 lakh liters along with 2 recharge shafts in the tank for percolation between Girls Hostel compound wall and new incubator building JNTUH, which covers the rainwater coming from the Girls Hostel building. Total rooftop area is 1282 square meters. The rainwater available from the roof of the building is about 8.30 lakhs liters per year. Stages of construction. Technical specifications of 1 lakh litre structure located between Girls Hostel compound wall and new incubator building. Capacity of the tank 1 lakh litres. Depth of recharge well 1 30 meters. Depth of recharge well 2 60 meters. Rooftop area 1282 square meters. Maximum rainwater that can be harvested in a year 8.30 lakh liters. Size of the tank 11 meter into 5 meter into 2 meter. PVC pipeline used 4 inch and 6 inch diameter. Recharge structure with a capacity of 1 lakh litre along with 2 recharge shafts in the tank of percolation between New Institute of Science and Technology building and Computer Science Engineering building JNTUH, which covers the rainwater coming from the buildings of IST and CSE building. Total rooftop area is 681 square meters. The rainwater available from the roof of these buildings is about 4.50 lakh liters per year. Technical specifications of 1 lakh litre structure located between New Institute of Science and Technology building and Computer Science building. Capacity of the tank 1 lakh liters. A depth of recharge well 1 30 meters. Depth of recharge well 2 60 meters. Rooftop area 681 square meters. Maximum rainwater that can be harvested in a year 4.50 lakh liters. Size of the tank 5 meter into 6 meter into 3.3 meter. PVC pipeline used 4 inch and 6 inch diameter. A recharge structure with a capacity of 50,000 liters along with one recharge shaft in the tank for percolation located between new quarters JNTUH, which covers the rainwater coming from the building of B5, A3, RSQ1 and RSQ2 quarter buildings. Total rooftop area is 2216 square meters. The rainwater available from the roof of these buildings is about 14.36 lakh liters per year. Technical specifications of 50,000 liter structure located behind new quarters JNTUH. Capacity of the tank 50,000 liters. Depth of recharge well 1 60 meters. Rooftop area 2216 square meters. Maximum rainwater that can be harvested in a year 14.36 lakh liters. Size of the tank 6.2 meters into 3.6 meters into 2.3 meters. PVC pipeline used 4-inch and 6-inch diameter. Recharge structure with a capacity of 50,000 liters along with one recharge shaft in the tank for percolation located between old quarters JNTUH, which covers the rainwater coming from the building of A1 and B1 quarters building. Total rooftop area is 975 square meters. The rainwater available from the roof of this building is about 6.50 lakh per liter per year. Technical specifications of 50,000 liter structure located behind old quarters JNTUH. Capacity of the tank 50,000 liters. Depth of recharge well 1 60 meters. Rooftop area 975 square meters. Maximum rainwater that can be harvested in a year 6.50 lakh liters. Size of the tank 5 meter into 4 meter into 2.5 meter. PVC pipeline used 4-inch and 6-inch diameter. There are 3 distinct watersheds covering JNTUH campus from which surface runoff is harvested for recharging the groundwater aquifers. Recharge pond with silt trap, inlet and outlet is constructed near Mechanical Engineering Department. Filtration bed is provided at the bottom surface of the pond. Rainwater will enter into the recharge shaft after proper filtration through filter media. 2 recharge shafts are also established within the recharge pond. The diameter of recharge shaft is 6 inch. These wells are helpful in recharging aquifers at various depths below the ground surface. All the above rainwater harvesting structures has been funded by Ministry of Water Resources, New Delhi, Government of India through the Central Groundwater Board Southern Region, Hyderabad, under Central Sector Scheme, Groundwater Management and Regulation. All the rainwater harvesting structures constructed under this scheme are currently functioning at the JNTU University campus in one of many measures taken by the organization to create awareness about the conservation of rainwater. This is an important step in the right direction. Conservation of water is essential not only for the present but also for our future. Water is our lifeline. Remember, catch every drop of water when it falls on a rainy day. The JNTUH authorities are monitoring the quality and quantity of groundwater in the campus. With the existing rainwater harvesting structures, we can collect around 75 lakh liters of rainwater in any normal rainfall year. Last year, after completion of the structures, we have collected about 26 lakh liters of rainwater. The JNTUH authorities have collected 4 lakh liters of rainwater and used it for the students of Manjeera Hostel. The authorities have observed 7.5 meter rise in the static groundwater level in the piezometers at different locations in the campus. Water levels measured in the 3 borewells on daily basis during the monsoon period were found to be 22.6, 23.6, 10.1 meter on 15 June 2012, and the corresponding water levels have been improved to 14.63, 16.46, 3.35 meter respectively on 1st October 2012, a corresponding rise of 7.97, 7.14 and 6.75 meter in groundwater levels have been registered, indicating significant improvement of groundwater levels. The monthly recharge in the structure of JNTUH campus due to the rainwater harvesting is as follows. Monthly use of harvested rainwater through the recharge structure at JNTUH campus.
I am specially thankful to the Minister of Water Resources, New Delhi, for funding this project. I personally thank all the officers of the Central Groundwater Board, Southern Region, Hyderabad, for their continuous technical support and approvals. Special thanks to Dr. Varadaraj, Member, Central Groundwater Board, Sri G. Sudarshan, Regional Director, Central Groundwater Board, Dr. P. N. Rao, Superintending Hydrogeologist, CGWB, Hyderabad. I thank our Honorable Vice Chancellor, Professor Rameswar Rao, Rector, Professor E. Saibaba Reddy, Registrar, Professor N. V. Raman Rao, Director, Academic and Planning, Professor G. K. Viswanath, Director, IST, Professor K. Mukkandi, Head Center for Water Resources, Professor K. Rammohan Reddy, and all other officers, teaching staff and students for their constant encouragement and support throughout the implementation of the project. Without their support, the project may not turn out to this shape. Thank you.